Okay, today we're beginning lesson 13.2, and our learning target is I can identify which statistics are most affected. I can identify which statistics are most affected by outliers and what shapes data distributions can have, and what shapes data distributions can have. And that's really going to be math practice 2. Okay? So what we're going to do is we're going to take a set of data and try to figure out a good way to show that data and also have a discussion about outliers. One way that we can display data is with something called a dot plot. So here's the set of data that we're going to use. Let's say that we have a small company and they have 12 employees. The salaries of those employees are $25,000 a year. Now I'm just going to use 25, and then I'm going to keep in mind that all of these are in thousands of dollars. So the first employee's salary is $25,000. Then we have somebody who gets paid $30,000. We have three that get paid $35,000. We have 3 that get paid $40,000. We have 1 that gets paid $45,000. Another one that gets paid $45,000. We have a $50,000 and a $60,000. Okay? Those are the 12 employees at the small company. Now, to make a dot plot, what we have to do is actually create a number line. And this is quantitative data because the data that we have is numbers. Remember, quantitative is like having a quantity of something. So we have to create a number line for this dot plot. It starts at 25,000, so I'm going to start there. I'm going to choose to go by an interval of 5. I think that makes the most sense with the type of numbers I have. So 25, 30, 35, 40. And I need to go to 60. Okay. So now what they do is you can show the frequency of each of these salaries that occur, and you can use either a dot, sometimes they use an X to show the frequency. So for example, 25,000, there is 1 of those. 30,000, there's 1 of those. Now 35,000 has 3, 40,000 has 3, 45 has 2, 50 has 1, and 60 has 1. Okay? And that would be the dot plot. Now you do want to label this as well. I'm going to call this salaries, and then I'm going to write in thousands so that the reader of the display knows exactly what I'm talking about and how it's measured. The nice thing about dot plots is you can actually find the median and the mean pretty easily. To find the mean, I would just have to add these values up and divide it by the 12 that there are. To find the median, I would be able to count in to the middle. These are my 2 middle ones, so in between 40 and 40 would of course be 40. So I can find my median to be 40. And like I said, the mean, I would just have to add up the data values and divide it by 12. I could do that if I didn't have the list of values. I could still do that from the dot plot. Okay. And the other thing I noticed from the dot plot is that this number of 60 kind of seems to stand out in comparison to the rest. I might be able to assume that that's an outlier, but we do have a mathematical way of actually calculating whether that's an outlier or not. And that's actually what we're going to do next. We're going to talk about an outlier, okay? Now, to be an outlier, you have to be a data value that is either much greater or much less than most of the other values. Okay, so much greater or much less than most of the other values. And like I said, there is a mathematical way of actually calculating that. Here's how you do it. Let's say X is the data value that we're discussing. Okay, in order to be an outlier, X has to be less than the first quartile minus 1.5 times the interquartile range. Now what that means, think about the interquartile range. That is the range of the middle values. If you take the range of the middle values and you multiply it by 1.5, and you are that far below the first quartile, that means that you're more than 1.5 times below that range, below that first quartile. Now, you could also be greater than the third quartile plus the 1.5 times the size of that range. So if you are more than 1.5 times the interquartile range, greater than, so added to the third quartile, then you would be an outlier as well. If we continue to look at this same story up here, let's say that we add the owner of this company. So here are the 12 employees, but let's add the owner who actually makes $150,000. Okay? If you think about where he would land on here, he would be way up here. So 60, 65, 70, 75, 80, and so on. I don't even have enough room to put him. He'd be off my paper. Okay? So does he appear to be an outlier? I would guess so, but you can't just guess. You have to figure it out mathematically. So what I need to do is figure out what my third quartile is, figure out my interquartile range, and see if he is more than 1.5 times above that third quartile. If I had the data value 150 on here, so let's just put an X and pretend like that's at the 150, okay? What I'm going to do is I'm going to count in and I'm going to find my first quartile and my third quartile. So if I take a look here, I'm looking for the median. So I'm counting in, counting in, counting in, counting in. Here is my median. Okay? If I use the actual numbers, it's maybe a little bit easier to do, but you can certainly do it from the dot plot. Okay, this is my median right there. Okay. Now I want the median of the lower values. So if I count in, okay, the median of the lower values, yep, is right here. So the first quartile is 35. Okay, I'm going to write that over here. Quartile 1 is 35. Then I want the median of these upper values. So I find the median, and it's in between these two. And that would make quartile 3, what is that, 47.5. Okay. I could use my dot plot just as easily to do all that dividing. Now, once I know these two, I actually can find my interquartile range as well. Remember, the interquartile range is how far apart are these two, the range of these. So 47.5 minus 35 is an interquartile range of 12.5. Okay? So the range of the middle numbers from here to here, they're 12.5 apart. So if you are more than 1.5 times 12.5 above this number, then you'd be considered an outlier. So let's actually do the calculating. If we took quartile 3, 47.5, and we added 1.5 times that interquartile range, which is 12.5, okay, this actually comes out to 66.25. Now, his salary was $150,000. Is that greater than $66,000 and a quarter. Yes, absolutely. He is definitely, the boss of the company is definitely an outlier, okay? Now, if we wanted to know outliers on the other end, we would take the first quartile, which was 35, and we would subtract 1.5 times 12.5, okay? If we do that, we get $16.25. So that would mean anyone's salary less than $16,000 and a quarter dollars, $16,250, would also be an outlier because they would be significantly lower than most of the values. So that's how you actually calculate whether something is an outlier or not. Now the next thing we need to talk about is how did that outlier affect some of our statistics, okay? So let's talk about the set without the boss's salary of $150,000. Without the $150,000, if we had calculated the mean, added them all up, divided by 12, it would have been $40,000. If we had found the mean with the 150, so added them all up and divided by 13, it would be 48.46. Now, the median without the boss would have been 40, and with the boss is also 40. The range from lowest to highest without the boss is 35, but the range with the boss is 125. The difference from the lowest salary to the highest salary is obviously going to be a lot more because his $150,000 was an outlier. Now, the interquartile range, the range of the middle numbers was 10 without it, and we found it to be 12.5 with it, okay? If you look at these, the mean changed a bit. It certainly went up because of that outlier. The median didn't actually change at all. The middle number really stayed exactly the same. The range changed a ton because of that outlier. The interquartile range changed a bit, but remember this is the middle numbers, so that outlier isn't in those middle numbers, so it didn't really affect it a lot. Now, the standard deviation, how far away the numbers are from the middle, from the mean. I think you can maybe assume what will happen here. The standard deviation before was 8.9. The standard deviation after was 30.53. Because that 150 was so far away from the mean, it really pulls that standard deviation up, okay? So what I can tell from the standard deviation is obviously without the 150 in it, they are grouped much more closely together than they are with the 150 in there. The only other thing we need to talk about is we had thought originally before we put the 150 in that the 60 may have been an outlier because it seemed to not really be grouped with the rest. What we did actually find out was, remember, to be an outlier we had to be greater than 66.25. So even though 60 is a bit higher than the rest, it's not high enough to be considered an outlier. So our assumption at the beginning that 60 was an outlier may not have been correct. And that's why we have to actually check outliers mathematically to be sure that they're really outliers.